Welcome to our first screencast in our F-Sharp series. If you're a subscriber at the $15 a month level, you already have the first chapter of our F-Sharp book, which was attached as a downloadable PDF file with our announcement post to our $15 a month patrons. Chapter 1 is essentially pretty long. It's about 50 pages, but hopefully you've downloaded it and were able to read some of it. We covered a lot of material in it, but we'll do a quick recap here. We covered the basics of the .NET platform, including its libraries, F-Sharp's interoperability with C#, and many other features. We explained memory and garbage collection. We explained the functional architecture of F-Sharp and the command query principle. And we explained that F-Sharp is immutable by default because it is a strongly and statically typed language that is functional first. But you can make a value mutable by using the keyword mutable. We also introduced some F-Sharp data structures, sum types or discriminated unions, and record types, also known as product types. And we explained that they have structural equality and don't allow accidental nulls, which makes it a lot easier to trust the integrity of the data that you're working with. We explained that in F-Sharp, the function is the base unit of abstraction. And we explained how side effects are handled in F-Sharp. For a quick refresher, F-Sharp's print statement has a value of unit, and we explained how unit in F-Sharp differs from the C# value of void. Unit in F-Sharp basically says, ignore me. Void in C# says nothing. We also explained function currying and partial application. And just to give you a quick refresher, here is an example of that. We're going to go into our F-Sharp interactive shell. And as you see, what we've done here is we've declared our function in the F-Sharp shell, and we can look at the type signature. Now, it's important to learn how to read the type signatures. Basically, what this says is that the value of F takes as its argument an input that's an integer and returns a value or a result that's of the type integer. And now we will show how function currying works, or how partial application works because of function currying, to be more precise. And here, as you see, what happened is we fixed one of the parameters of our function. We fix it in place where add2 takes the function that takes two parameters, which is really one argument, and partially applies it to a function that takes one argument and adds 2 to it. understanding the concept of the function currying and partial application is a very important thing in functional programming. So make sure that you understand this concept. In Chapter 1, we also introduced F-sharp's list and seek or sequence modules, which we call seek for short, and some of the most commonly used methods in each of those modules, which are map, filter, and iter. And we also introduced some important operators, such as the forward pipe. And the forward pipe looks like this. In case you didn't get to that part in the chapter yet, that's what the forward pipe looks like. And that is the hallmark. That is a hallmark of the F-sharp language. The forward pipe takes a function or value to its left and passes it through to the function to its right, which allows you to specify the parameter of the function before the function is called. So what you're doing is you're taking a function or value and applying it to the parameter that follows. Pretty simple. Now, what we're going to do is we're going to use what we learned, or what was covered in Chapter 1, to demonstrate how we would solve a real-life problem in F-sharp where you're going to use all of these things. And one of the most popular sets of problems that people work on are the Rosalind DNA problems. These are real-world programming problems that have to do with genome sequencing. So you will actually see programs like this. And the first Rosalind problem is we are asked to count the number of nucleotides in a strand of DNA. Now the nucleotides are the letters A, C, G, and T. And we're going to count from an input file, which represents a strand of DNA, the number of A's, the number of C's, the number of G's, and the number of T's. What I always do is I always start every F-sharp program by opening the system and system.io namespaces so I don't forget. Another thing I like to do is I like to change the color of the output. So now, looking at our first problem in the Rosalind series, if we're asked to take a data file that's a text file representing a strand of DNA and count the individual elements, the individual A's, the individual C's, the individual T's, and the individual G's, how do we do that? Well, first we would have to read the file. And that is what we're doing here. We download the file from the Rosalind site. And your download path will, of course, be different than mine. So that's the first function that we write. The function that reads from the downloaded file. And that takes that information and then applies it to the functions that we're going to write for counting these elements, these nucleotides. So how would we do that? Well, how about we have a function called let count any letter. And what we're going to do here is something called type annotation, which is another thing we covered in Chapter 1 in our book. And what that does is it allows us to define a function and make it clear to the F# compiler what the type signature of that function should be, what kind of values it returns. Should it return a string? Should it return a character? Or should it return an integer or a float or a bool? Well, since we're reading from a text file, we're going to be dealing with a string type. So that's going to be our first parameter in our argument, because a text file is treated as one long string in F#. But we're concerned with more than just the string. We want to extract the number of each character, each A, each C, each G, each T from that string. So we're going to add another parameter, and that is the type char. And now what we're going to do is we're going to use the forward pipe, and this font is called Code, by the way, and all it is the vertical bar and the right angle bracket. But when you type it together like that, it Code lets you gives you a ligature. Now, if anybody is not real happy with that kind of font, please let me know. Give a holler, and I will switch back to the plain, boring, vanilla font that is standard for the mono-develop IDE. But the ligatures will come in handy later on when we build parser combinators and when we work on parsing an actual EDI file. It makes it a lot easier to read the different operators that we're going to be working with as we advance. So try to get used to this font. Please give it a chance. You'll like it, I promise. And what we're going to do now is we're going to pipe this into, we're going to filter out the letters that we want to count. And how we do that is by treating that string as a sequence of letters. And we're going to filter out each letter that we want to count. And we're going to declare our function here that does that for us. And this function says, for all the letters in this string, do this to it. Filter this out. And then what we're going to do is we're going to pass the result of that to get the length. The length of each list or sequence of characters. The sequence of A's, the sequence of C's, the sequence of G's, the sequence of T's. We're going to get the length of each of those, and that's how we're going to get our count. Right? We're not done yet. We filtered out the letters. We passed it to the length. But what we don't have is each individual element. But we're going to get that now. And this is what's really annoying about IntelliSense in the IDE. It sometimes does that. It wants to type something that you really don't want. So what we're doing here is we're taking the result from count any letter. We're going to pass it through to this function. And in here we have a nested function, which is, our values for the individual A, C's, G's, and T's. And we're going to print out the number of each one of those. And then we're just going to finish up down here. And what this does is this takes the input after the file is read, feeds it to this function here, which then in turn defines the values for each element, each nucleotide in the strand of DNA, which we set equal to the call to this function here, where we're counting each letter that's been filtered out in the string. Let's see how that works. And there it is.